Hello everyone, in this video we are going to discuss about another type of basic gate, that is OR gate. This is the last video for our basic gates. In the previous video we discussed about AND gate and NOT gate, and this is our last basic gate. We have three basic gate: NOT gate, AND gate and OR gate. Now in this video we will discuss about OR gate. So let's begin our video. First of all, what is OR gate? It is the logic gate which produces high output if any of the input is high. In the case of AND gate, we have seen that if all the inputs are high, then only the output of AND gate will be high. But in the case of OR gate, if any of the input is high, then the output of OR gate will be high. Like in the case of AND gate, we have two or more than two inputs in the OR gate. Plus sign is used to show the OR operations, but in the case of AND gate, we use dot sign to represent the AND operations. AND operations represent the Boolean multiplication, but whereas this OR in the Boolean addition. This is the symbol used in the digital logic to represent the OR gate. Here A and B represents the input of the OR gate, whereas A plus B represents the output of OR gate. Come to the truth table for two input OR gate. Before going to draw the truth table for two input OR gate, let's see how many possible combinations of the inputs are there. The total number of possible combinations for the input is given by the formula n is equal to 2 to the power small n, where this small n represents the number of input. Here in our case we have two inputs, so the total number of possible combinations will be 4. Possible combinations for the input A and B is shown in the table here. The possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. And also it contains a column which shows the output of the OR gate and is represented by y is equal to A plus B. Output of OR gate can be written by using the definitions of the OR gate. From the definition of the OR gate, you can see that the output of OR gate will be high if any one of the input is high. In four possible combinations of the input, we have only one case where both the inputs are low and the output of OR gate is also low. There you can see it in the table. Come to the timing diagram of OR gate. We know that timing diagram represents the graphical form of input and output. In this video we are discussing about two input OR gate, so let's consider two input waveform. Let my input waveform be input A and input B. Here I have written the number 0 and 1, which represent low and high, and as you can see in input A and input B, they are changing their value in certain points. This red dot line represents the point where the input A and input B are changing their values. In the first red dot line, you can see that input A is changing its value from 0 to 1. Likewise, input B is also changing its value from 0 to 1. For the second red dot line, you can see the input A is changing its value from 1 to 0, but the input B is still in high. Likewise, in the third, you can see that input A is changing its value from 0 to 1, whereas the input B is changing its value from 1 to 0, and similar to the other red dot line. To draw the graphical representation for the output of OR gate, first of all we need the truth table of OR gate. Here is my truth table of OR gate. It shows that the output of OR gate will be high if any one of the inputs is high. This will be my possible outcomes. I will explain it here. As you can see from the truth table, the output of OR gate will be low if and only if both the inputs are low. In the first case we have seen here, input A is 0 and input B is 0 and output is 0. Likewise, in the second case we have input A is 1 and input B is also 1 and output is also 1. You can see it in the truth table. If both the input is 0, output is also 0, and if both the inputs are 1, then output is also 1. Similarly, for rest of the red dot line, you can draw the output for the OR gate. In this logic gate simulator, we are going to verify the truth table for OR gate. We have seen that OR gate will produce high output if any one of the inputs is high. We will verify this statement here. This is my OR gate, and these are my two inputs, input A and input B, and this will be my output Y. You can see red color here, and this red color represents high input, similar to the output. If it is red, then the output is high. If it is white in color, then the output is low. First of all, I will make my input low, and I will connect this to my OR gate, and also I will connect my output to the OR gate as I have connected here, and both the inputs are 0 and the output is also 0 here. But if any one of the input is high, I will make it A as high here. You can see here the output is also high. Likewise, if A is 0 and B is 1 or high, you can see that output. If both the inputs are high, then the output is also high. This verifies our truth table for OR gate.